Welcome, everybody. Today we're going to be working on Module 4, and we're going to be introducing a bunch of new concepts into the mix here. And I'm going to begin by talking about classes and objects. And I usually say it the other way around to say objects and classes. So one real important thing when we start working in a programming language is to understand that modern programming is really very strongly built around objects and classes, right? And you'll often hear this terminology as you're talking about it. Well, people will say, aha, that language is object oriented, right? And what that means is that we treat a complex collection of both data, features, and capabilities with one named structure that travels with the object. An object is built on a blueprint called a class. So for example, if I'm building a house, right? So Anthony, you've heard this example before, right? If I'm building a house, do I just run down to Menards, buy a bunch of 2x4s, a hammer, nails, and get busy to build my house? No, that's not how it works, right? I mean, not that you can't do that, you sure can, but it sure helps if you have a plan first, right? And so when we build a thing called a class is basically a blueprint for building the real object. So in other words, I have all this detail in the blueprint that tells me what materials I need, what sizes it should be, how the things are finished, what fasteners, every little bit of the plan is built into that blueprint. But the blueprint doesn't become real until I build the house. And more so, I can take that blueprint and build one house and then build another house next to it that's basically the same house, but it might have like different siding or a different roof style or maybe different windows or different yard or whatever, but it's still basically the same house. It's built on the same blueprint. So the actual house is an object. It's the real thing. It's an instance of the blueprint, and we're going to do a lot of terminology like this, by the way. And the blueprint basically just holds kind of like the archetype of the house, but it's not a house. It doesn't become a house until we instantiate it and make it an object. The class is the blueprint. The object is the actual thing in use. And the beauty of doing a blueprint or a class and then creating objects from it is we can create objects over and over and over again based on that blueprint with the same capabilities. However, every object that's created is unique unto itself, right? So even though you might build 100 houses off of the same blueprint, and you do go through subdivisions where there's houses like that, right? It's like, oh my God, all these houses are the same. How did that happen? Well, it was cheaper to use one blueprint, than to come up with a bunch of different, architectural plans. But every one of those houses is a unique entity. But every house has all of the features of that original blueprint. It carries with it. So that's kind of my little standard speech, but then you'll see it reiterated here. So it says Python is an object-oriented programming language. Almost everything in Python is an object, right? And the same is true with JavaScript, by the way. And every object has its properties and methods. Now remember, methods is equivalent to the word functions. So properties usually are equivalent to the data structures that travel with the object. A class is an object constructor or a blueprint for creating objects, but it's not an object in and of itself. Right? To create a class, you just simply use the class keyword. Now, this is a very, very simplistic one. So what's happening here is we're defining my class as a class, and all we're doing is we're giving it a property. It doesn't do anything, but it has data where x equals 5, So X is 5. That's all that class does. So I'm not going to go into the try it out thing. Where it gets a little weirder is how do I show that it's a thing? All right, well, what happens is I have to actually create that class. So notice we called it my class. So I have to actually create my class as a thing. Now notice what I do here is I call it with parentheses that calls the blueprint and creates a version of that class file in a variable called P1, right? But P1, it's not like an integer or a string. It contains all the features of that object. Now, we're using a very simple one right now. It just has one data property, but it could have 20. And some of those data properties could be complex ones like lists, right? And then it could also have a bunch of functions built into it, which we call methods. And all of that travels. So like, for example, if this had, 20 data properties and 15 methods, P1 would represent all of that. So it's a house, not a blueprint. It's a house that has all those features. And the syntax is insanely simple. This is why object-oriented programming is so cool, because all the capabilities of that class are basically encapsulated in this. And then when I use dot notation, I can access one of the properties. So if I did print p1 dot x, it pulls back that 5 and puts it on the screen. Very, very simplistic example, but that's what it does. Right? We'll see that in action. Now, there is a special function that we add to class structures, which is called the init function. And one thing I'm going to say right now, and I'll probably say it multiple times, and you'll probably still mess it up. And how do I know that? Because I did like multiple times until I got it. The init function is declared by doing 2 underscores, not 1, 2 underscores, the word init, and then 2 underscores. What invariably a lot of people do is they just do that, right? 1 underscore in it, 1 underscore, and it's like, it's not working. I don't know why. And it's like, well, okay, because you didn't do 2 underscores. And it's super easy to miss. Mark my words, you'll probably do it at least a couple of times. Hopefully not, but maybe, right? What's kind of interesting about the init function, if you know another object-oriented programming language, we basically call this the constructor function. So when I call the object, or call the class to build an object, if this function exists within it, this will execute to build the object according to the instructions inside that function. So for example, right, if I have a class called person, I define my init function, notice double underscores, and then anytime you have a method inside of a class, we use what we call the self-referencing piece. That's required in the init function. It's actually required in all methods inside of a class. You always have to refer to self. And then whatever data you're sending in, if any, right? Sometimes this is blank, sometimes there's stuff being sent in. But what this init function would do is it would capture a name and an age. It would take the name and then apply it to the internal variable by the same name, where this is way different than other languages. So like my comparison would be or JavaScript, Java, C#, most of those styles of languages. We usually declare the data separately and then initialize it. So in other words, we'll have an area up here where we declare all the variables and then we apply values. In Python, I can do that all in the init function. So in other words, this is data coming in from the outside world. It travels to this spot. It gets assigned to the internal data property or variable, if you want to think of it that way, called the same thing, right? So self.name means like, which name are you referring to? Well, this name, the one that you're in right now, this object's name. So think about this. Every person is a unique entity. Like even if you're a twin or a triplet and the DNA of your twin is identical, so it's kind of like a really good example of a class and an object, you still have different names. Technically, you have different birth times at least, right? You might have been born on the same day, but it's slightly different times. So your age is actually slightly different. You know what I mean? So even though you're identical in every other way, you still have your own name and you still have your own age. And this is true for every person on the planet, really, right? It would be very rare for people to have exactly the same information. But this is taking the data, applying it to internal variables, and then what we can do is we can create a person object. So this would be calling the person class, sending the name, sending the age. They're received here, right? The name goes into the internal variable, age goes into the internal variable or data property, if you will. And all of that is stored inside a thing called P1. Then if I want to output the name, I can do it. If I want to output the age, I can do it. Now this one I'm going to go into because as you can see here, I mean, this one's pre-done, but let me show you kind of some of the magic sauce here is I can create a second person, right? So I'll call the init function or the constructor function, and let's create Joe, and Joe is 23. And then I can take these and just change them to P2. So it's a new object with its own name and age. They're using the same blueprint. So when I run this, it will then output Joe 23 because I'm dealing with a separate object there. They're both using this blueprint to build themselves, but once they're built, they are unique unto themselves. But they use the same blueprint. So this is kind of the, albeit a primitive example, right? Notice the init function is automatically called every time the class is being used to create a new object. All right, kind of interesting. There are some functions that are built in. All right, so here's another function, and this is one that we kind of utilize a bit too. This has a double underscore here, and this is what we call the string function. And this function controls what should be returned when the class object is represented as a string. So for example, if I run, okay, so check this out. If I run the string representation of an object without the string function, we basically get what we got. So if I output this, I'll just show you what it does. This is kind of weird. So the object doesn't really print very cleanly. Really what it's giving us is where it's stored in memory. That's actually what it's returning. This is very, very strange, right? And frankly, not very useful. However, if it has a string function built in, the string function will return whatever details we want to send back if we call it. So in other words, if I do a print and I'm expecting to get a string back, I'm predefining what goes into that string. So for example, that'll run and it'll put John 36 on the screen. And notice how it's doing it. Where are the parentheses coming from? Well, they're coming from right here. You don't want those parentheses? Well, you can get rid of them. I mean, you can make it like, you can actually put other stuff in here. You can say, this is John, comma, he is 36 years old. So you can have it say whatever you want. And keep in mind here, if there's other data fields or objects or whatever inside of this class, those can all be handled that way too. So this is just kind of a way to be able to output what an object is directly by just saying print P1, whatever the object name is, and have it return something more meaningful than that weird memory location that we were just looking at. Right, the memory location. I mean, I'm not sure why they did that in Python, but they did it, right? So this is kind of a string function. If you want to directly print an object, you have control over it. If you don't do this, you don't include this in your class, then it will output the memory location of the object. All right, I'm not sure why that's useful, but I guess if you're worried about memory management, perhaps it is useful. All right, so the other interesting thing about objects is objects can contain methods, which is another way of saying functions, right? So here's a terminology. Basically, methods are functions that are inside of objects. So when you create the object, the function travels with it. This is pretty weird. So not only can it have data fields that hold information, but it can also have functionality. Now, this is a very simple function. It's just putting text on the screen, right? So I can build my object, and then I can call the object, and then with dot notation, call its internal function, and it will execute whatever code's inside there. In this case, it's just putting a string on the screen, but it could be something more complex like math, just to show you that it actually works, right? So this is pretty cool. An object like this or a class structure can have very complicated functions that do very specific tasks related to what that object is. So for example, all right, we're building a person object. So you think about, okay, what are people, what data does a person carry? Well, a name and age is one thing, right? But you could also have like address, social security number, email address, whatever. And then methods or functions are kind of like capabilities. So maybe like if I was building a car class, one of the capabilities of the car class would be to drive or to stop or to refill the fuel. Those would be capabilities of that particular object. A human might walk or sit or sleep or eat or jump or whatever, play basketball. I don't know, or like me, play guitar, that might be a function for that particular object. That all comes down to the logic of the object that you're building. And there's another weird feature inside of this, and we've already seen it, right? Which is the self parameter. And this is a really, really weird one to explain. For those that have previous programming experience, and it's not many of you that have done objects and classes, but in most other languages, the keyword that we use in place of self is this. So if you ever learn like Java or C#, and you say, and the way that I always think about it is like, which object are we referring to? This one, the one that we're looking at right now. So that's kind of what self is. But the point here is that you can skip, for example, using the keyword self if you want, and you could actually put in any name of your choice. And they're being really silly here, and they're saying my silly object instead of self. But the standard is really to use self. And I would recommend, and this is a personal recommendation, that you stick with using self because it's clearer, right? If you feel that comfortable with it, that you can use other names, go for it. The point of it is these are still referring to self, right? Especially this part of it. They're just using an alternate version. It is also possible that if you have a property inside of an object, so for example, John has an age of 36, but if we decide, oops, that was 4 years ago, now his age is 40, notice I can actually change the data property of an object using the same syntax I used to change a variable. Now think about this. This is basically an internal variable for the P1 object. So I can go in there and I can change it. And just like I do a variable. In some cases, you want to be able to have properties of an object that change. And I'm just going to say this. And sometimes you don't want to allow that either, right? It depends on what we're working with. If you want to delete a property, you just want to remove it, you can use the delete command. That's kind of weird, right? I don't use that one often, but it does have its place. If you want to delete the whole object, you want to remove it from memory, you can use the delete command for that. So you can delete an object's properties, or you can delete the entire object. Now, keeping in mind that Python is a modern language, it does what we call automatic garbage collection. So normally when the program stops running, it lets go of the objects and memory is freed. But if you create a bunch of objects, they're still in memory, and you keep creating more objects, and you're trying to run a bunch of programs, that chews up your memory. It can have an impact on system performance. So there are times where you do choose to actually delete an object from memory. Right. All right, we're getting to the bottom of the list here. When you're doing the building of an object and you don't know what goes in it yet, but you know, same stipulation with building a function, you can throw the pass command in there to have it kind of skip over it. That works with classes as well. Right. So that's kind of the overview of what objects and classes are. We'll do practice with them, and you'll see how they operate, and then there's more value when you see that. Another thing, and we've been doing this a little bit, is this concept that we can import stuff from other files or collections of files and import them into our program. Okay, so all right, so let's take a look at this here. They have a module named my module that has one function and one dictionary. We haven't learned what a dictionary is, but it's very similar to a list. But it's a data structure basically, key value pairs. And if I wanted to import that piece of information into my program, I can use these import statements. Now we've done a tiny little bit of this, right? If you guys remember, I think we did it with like a math function. And one of the things that we're going to be playing with tonight is building our own helper function and having that available for all the programs that we build tonight. And this is kind of like one thing that experienced programmers do is like, if they're always like coding the same kind of stuff, and I've already created this thing that does this magical little action, and I don't want to recode it, I can just put it in its own little library of functions basically, and then I can import it into my program and utilize the specific tool. But the example here, just to kind of like drive it home, is we have a module called my module, right? It has one function and one data structure. Okay. I want to import that capability into my program, so I call it. So my module here is actually the name of the file that contains the code. So there's a mymodule.py sitting somewhere. So from the mymodule.py file, import person one. What is person one? You're importing this. So now once I've imported that, I can call it and use it in my program. I can use it as a piece of information in my program because I'm calling it from an external source. This is a very simplistic example, but all right, so that's the first example. Let's look at the second example now. This one takes us to the documentation here, and basically what they're showing is the generalized form of this. So one thing that you can do is you can import an entire file. So if the example that we looked at here, we are importing one part of that external file, which is this. If I change my syntax and just import the whole thing, if there's like 50 functions in there, I'm importing all of those into my program. Now this approach to building programs, by the way, it's kind of like what we call the API approach. Like, in other words, I have like this already pre-built set of things, and I don't want to recreate them. I just want to utilize them. I can import them and utilize them in my program. Right? Yeah, very, very cool, by the way. And this, keep in mind, my module could contain classes, objects, functions, data structures. Yeah, it can contain anything. And all of that can be imported. So you can have these very complicated things that you're importing that are pre-built. And all you have to know is the syntax of what's in there to pull it in. So it takes a little bit of knowledge. And one of the more common usages we see, frankly, especially early on, is we'll import a class file if the class file is not declared within the file we're working on, or we import like a math library to perform a certain math function we can't do otherwise, right? But ultimately, what this approach really gives us is the ability to pull in pre-built code from libraries so that we don't have to build the code. We just utilize it. And that's what modern object-oriented programming is all about, folks. So you learn the basics like variables and loops and lists and, you know, if statements and all that. And then when you learn that, oh, there's this cool library, and I was teaching my students last night, my intro to AI class, you know, there's all these pre-built libraries that automatically do like computer vision and natural language processing. And I can just import that into my Python program. And I have AI stuff in my Python program. I didn't write any of it. It's open source. All I have to do is download it, import it, and it's there. That's crazy, right? Right. But first, you got to learn how to walk first before you run, right? All right. A couple more lecture topics here. And one thing that becomes kind of an apparent issue in programming very quickly, and Greg identified this while we were building the assignment. Like we tried to delete, basically clear a list or delete the list is what we were trying to do. And Greg brought up the question, and the question to that answer to that question, Greg, is also yes. It shows it's recording on my end. But the point is that you're trying to catch errors from happening. So like, I don't want somebody to delete something if they really don't intend to delete it. Now, another thing that happens in coding, and this is where it gets a little weird, is sometimes you run a program and you're expecting, for example, to maybe import a file or to get input from the user, or you're expecting a certain kind of entry from the user and they're not giving you the right thing. What happens now? So like if I was running our assignment from the last module, you know, the vacation planner, and it worked fine, typing 1, 2, 3, 4, 5, or whatever number I would type, actually it would work fine. But if I started typing letters or words and I pressed enter, my program would crash. It would stop working, and not in a pretty fashion. They would just throw all these weird compiler errors and boom, you're done, right? I was like, what happened? I don't know. This is horrible, right? So they've built this structure in Python called try except. Okay, comparison to other languages, because I think this is necessary. If you know other traditional languages, most other languages call this try catch. Now, generally how this works is we have the code that we want to run that potentially could throw errors. That goes in what we call the try block. So this would be our normal code goes here. Then if we don't get the input we expect or something goes wrong, we have a handler for it, an exception handler is technically what it's called. That's where the word except comes from. So what happens, like for example, I'm trying to import a file, but the file's not there. I want the program to crash? No, maybe I should just put up a message that says, hey, that file import didn't work, try again, or whatever, you know, some sort of a message or a thing. There's also the else and the finally. We'll handle those when we kind of get to them. Let's take a look at a really basic example. So in this little example that they first put up on the screen, we're telling Python to print X. However, if you look at the code, right, in very simple code, X is not defined. So it can't do it. So let's try this, right? So we try to print X, an exception occurred because there is no X to print. However, if I say X equals whatever, and I run it, eventually it will say whatever, right? Because now it exists. So this is an example of I'm trying to run code, and if it's possible for the code to run, it will do it. This is like my normal code that I would write. However, maybe this piece of information is dependent on the user, and the user, instead of typing something in, decided to press enter and not type in anything. So X becomes undefined. Now I have a way to handle the exception that happened or the error that happened. This can be used in a lot of different ways. And normally when I teach like these concepts to like my 3 credit students over at Gateway, this is like end of the semester stuff, right? Exception handling. But a well-written program, especially when you're dealing with input and output from the user or input or output to external files, this becomes a critical piece. I think, a critical piece. All right. If you have a bunch of different exceptions, you can actually have multiple exception statements. I think that's kind of weird, but there's actually, for example, different types of exception errors, and experienced programmers will learn this. So for example, like if I was writing a program that was relying on a network connection on the internet, and the internet's down, then I would have a internet error. If I have one that's an input error from the user, if I have a file exception because the file doesn't exist, they're all different types of errors. If you don't specify a specific type of error, then you can just use a generic. But you can also have multiple different error types listed. I would call that more of an advanced skill. There is also an else here, and this is kind of like the else for the while loop and the for loop. I don't see it used much, but it is, in some people's minds, a useful tool, right? So here's the weird thing about else. If the try works, actually, let's just run this. This is kind of weird. All right, so it printed hello, and then it printed the else. So the else will always happen. That's kind of the point here, right? There's also another weird structure, and I don't understand why Python has both, but the what else does finally kind of does the same thing. So this one will print no matter what, kind of like an else. So once again, I don't understand why Python has an else and a finally, probably because while has an else and for has an else and no other languages do, so I don't get it, right? So I would have to like pick the coders' brains that built this, or there had to be a functional reason why they did this. But it's kind of a way to force code to run if it goes through a try block. Kind of like me, like running a program and having program complete at the end. That's not really required, but somebody might think it is. All right, so, all right, I think that covers all the lecture topics, almost all the lecture topics. One more. All right, so there's this continue keyword. And okay, we ran into this one before, right? So remember we were doing our while loops in the assignment, and if like the users made a certain menu choice, we would break and it would break us out of the loop. Continue would run the loop over again, but it would skip all the statements that follow, right? That's what continue does. So that can actually be useful in try statements as well. That's kind of the point. All right. That's all the lecture stuff, folks. Now we're going to go into the labs, but I think what would make a lot of sense, because we've been going for a while, is that we take a 5-minute break. So it's 7:15. We'll come back at 7:20. So I'll see you in 5. All right. Now that we've done all the lecture bits, we're going to start working on this first lab. And it says we're going to create a class representing a person. Classes are used as blueprints to create objects. We will create a file to make validation of data easier. All right, so that's going to be the helper thing, and that's the piece that I just mentioned. I may or may not do at this point. We'll kind of see, as we're kind of moving forward. I'll just kind of do it by feel. The important part to me really is these tasks. So let's look at the requirements. It says create a class called person. All right, then we'll create an initialization function with 3 parameters. All right, so self, name, and age. Self is always required, and we'll talk about that as we're doing it. And then we'll create properties for name and age, and then try assigning values to it and make sure that they're getting there and that it's all working, right? So they're kind of giving us some example output, and I think this is really kind of watered down a little bit. All right. And then it says here, a return statement will end a function even if it's in a loop. And I'm not sure what that has to do with anything here, because I'm looking at my example for last year and it's not even part of it. So I think I need to revise this description a little bit next time I put it out there, but guys, follow along with me with what I'm doing here and you'll be fine. All right. First things first, I have preemptively created a folder in my file system for the Module 4 labs. You can see that it's open up here in Visual Studio Code. I'll begin by just creating a Module 1 lab 1.py file. And then we're going to start building the class. So I'm going to build the class here. And this is a little bit unusual, right? Because there's kind of two different approaches to doing this. And I'm starting with what I call the more simplistic approach. So let me explain in advance what I'm doing. Is I'm going to create the blueprint inside the program that's creating the objects, which is not the typical way to do it. So at some point, I'll demonstrate the alternative approach, just so you guys can see what I'm talking about. But generally, when I create a class structure, which is a blueprint, we usually leave that as an external file and then import that into a program utilizing it, right? Because you don't really want necessarily, like, for example, if you walk in the house and the first thing you see is the blueprint, right? It's kind of irrelevant. You just want to walk in the house and be in the house. But we're putting the blueprint inside the house, if you will. All right. So first things first is I'm going to define a class called person. Kind of like we do a function, but the keyword is class. Right. Have some notes here that I typed up last time. I'm going to drop them in and see how relevant they are here. All right. So the first thing that we're going to build here is the initialization function, or method, as they call it. And then that's the tool we use to make each instance of the class. So every time we create an object from the class, that object is called an instance of the class. And then the process of creating it is called instantiation, right? I always have a problem saying that one, but whatever. By default, it will include this for us, but we can overwrite it. Okay.
Did you mean to name it Module 4, Lab 1?
Yeah, you know what? Yeah, I did mean to name it that. Let's rename it. Thank you. Who said that, by the way? All right, thank you, Alexis. Yeah, details, right? But details matter. All right, so inside here, inside the class structure, notice I'm indenting, so it's inside the class structure. I'm going to define the init method. So 2 underscores init, 2 underscores, set of parentheses, and a colon. Whenever you do methods inside of a class, you always have to have as the first parameter for any method, whether it's accepting data or not, the self-referring parameter. This is required. We did see from the example that you can name it really anything you want, but self is kind of the standard. The comparison to other languages is this. And given the fact that you can name it whatever you want, you could use the keyword of this, but I won't. I will use self because that's the Python standard. When we build our person object, just like we saw in the example, we will use a name and we will use an age. These will be kind of the internal variables that we're receiving from the outside world, but applying to internal variables. And the basic structure, by the way, is exactly what we saw in the examples, which is just to say self.name equals name. So name, the singular name, comes in from the outside world and gets assigned to the internal data property, is really what it is, called name. So just to show you as an example, I could actually just do this, and this would work too. It's just kind of considered a no-no because then it gets confused. It's better to include self because then it's clear when you look at the code that it's the internal data property. That's kind of the reason for it. We'll do the same thing with age. So we're just going to say self.age is age. All right, so now I'm going to drop in some comments. So the first thing I'm going to do is, and the reason I'm dropping them in is I have them pre-typed. So hey, let's just drop them in and read them and see what I typed last time. It says every method, function, and an object needs the first parameter of self. Okay. Talk about it. Self is the current instance of the class object, right? I think that actually says it pretty clearly. Next little comment I'm going to drop in here, and I'm not sure if I should put this after or next to, but that's what I want to say. So self.name is the scope of the object. Name is in the scope of the object. Gotcha. Okay. I don't know if that's actually clear or not. And for age, I typed this. And once again, I'm just including these because I already had them. You know what? I'm just going to put them on separate lines. I think that's easier to read. So you can also think of these as properties or data fields, variables that travel with the object. So whatever value we set here stays with the object that we create with it. Now, the fact that the init function does receive external data means that when we construct the object from regular code, we do have to include those pieces of information. Otherwise, it won't work. And that's an important takeaway. It is. Right. So this code here is the class. Now, normally, and I say this so you guys are aware of this very keenly, that when I usually create a class, I'll store this in its own file named the same as the class. So I'd call this person with usually a lowercase p that contains the object person with a capital P. And I want you to notice that too. The capital, this is a convention, by the way. So like in most programming languages that are object oriented, a capital letter at the beginning of an object name or a class name indicates that it's a class. It indicates that it's a complicated structure. It's not just a simple variable or something like that. I'm going to come back out to the margin, right? And I'm going to do a little divider here. And I don't normally do this, right? I'm doing some of my ASCII art here. I'm just putting in a divider to show you that the class definition is separate really from the rest of the programming code. This code, if I run the program, will not execute. This is non-executing code. This is a blueprint. Now I need to create the house. That happens in the regular program body. So that's why I'm typing this here. In fact, I would say the code above is non-executing. It is a blueprint to build objects. If that's helpful for you. Right. Code below is the code that will run. And here's where we will build the object. So for example, I'll create a variable called me that's going to hold a person object. So I'm going to call person, notice the capital P, set a parentheses, and inside of it, I will send a name. So I'll just do my own name, and I will send my age. Okay, so my name and my age going into the object. Now that I've created the object, so think about what's happening here. We're calling the class structure, and isn't it interesting when I highlight it, it tells me what the data properties are. Name, it's assuming is a string, and age, it's assuming is an integer. And I didn't even declare that. Right? Thank you, Python. So this will call the init function, receive name and age, and apply those to the data properties or internal variables, if you will. Now, I need to make sure that that actually worked. So I'm going to do a print. So I'm going to print, what am I printing? Me dot name. So I'm printing the name that's inside of me. And then I'm going to print me again with the age. And to prove that it worked, let's run it. So Control S to save, and here comes the runtime. So you can see it printed my name and it printed my age. And you know what? I can do this over and over again. So I have another example, and this is funny Greg will think it's funny because last year I used my friend Greg, who also has two G's. He was at the time he was 58. He's probably 59 now. So it just increase his age. Um, but this is me. I'm an object that's built on person. This is my friend. He's also a person built on the same blueprint. He's got his own name and his own age. Right? So let's run it again. And then you'll see that my information printed and Greg's information printed. So we used one blueprint, created two objects, each with their own pieces of information or capabilities, your unique identity to them. One house has white siding, the other one has slant and stone siding, whatever. Two different houses, same blueprint. All right. Let's see what the other instructions are here. I'm looking at my other code going, that can't be it, right? Create properties for name and age. We did that. Create three objects using the person class. Get user input for the creation of one of the people. Output the names and ages. Okay, so let's do that part. All right, so for the next one that we create, all right, so two of them were hard-coded. We just hard-coded it, created the people. Now I'm looking at my example here, trying to see how I did it. Okay, interesting. So let me show you how I did this last time. So I created, well, I called it best friend last time. I guess we could do that. So I'm creating another variable here. This is going to hold an object. And this is like so weird with Python. And I'll say this again, is the fact that, we're creating a variable name and what are we storing inside of it? It's a complicated object. And so far it's a simple object, but it can be very complicated. So what I'm supposed to send in, so I'm supposed to do this. I'm supposed to do person and then do name and age, right? And notice as I stop typing here, how the IntelliSense inside of Visual Studio is going, oh, hey, the next thing that you need to do, and of course I moved my mouse off of there so it stopped, but let's recreate the magic. Right? It did the parentheses, and it's telling me that I can type in, or I should type in these two parameters are required. Now, I could do this a couple of different ways. I could do two separate input statements, capture a name, capture an age, store them in variables, and then throw those variables in here, send it to the person object, and create best friend. Or I could put the input statements directly inside the statement. So in other words, like so, and I'm going to grab both of these at the same time. So, and copy paste them. So this is what I did. And I'm going to go ahead and close the Explorer so you can see the whole thing. And Alexis, I do see that you have your hand up. So in place of the name, right, I'm just doing the input statement right in line. I'm going to just prompt right from here. They're going to type in the person's name. And then I'm going to ask how old the person is. And I'm converting to an integer for the second position. But all of this technically is name. All of this technically is age. Alexis, your question, comment?
Yeah, it was kind of up in the actual class. So like I've always used this obviously when working with Java, but it was something that I always had trouble understanding, and I kind of get what you were saying with the is the scope versus is in the scope, but I guess I just wanted to confirm. So, like, basically, it's for instance, and this might be kind of getting ahead of things, but like, if I were to create an array of persons or like so-called people, um, if you're changing something for like a person at index whatever, the self dot name would just be like that specific like person in that specific memory right there for name versus like regular name is like what is being passed in, right?
Correct. Yeah, right.
Okay.
And normally, like if I was doing this in Java, I wouldn't name it like this at all, right? There's under no circumstance in Java would I name the incoming parameter the same as the internal data property. I just wouldn't do that. right? I would do something like, I might like abbreviate the incoming thing to something like this, because in Java, I always worry about like polluting the variables. Right? I would name them something different by intent. Okay,
Okay.
but let's go back to like Python kind of doesn't care. However, and this is the big however, I could do this without including the self thing in here, right? And you know what? I should show you guys, from my, in fact, let's just do this. And I think this is kind of an interesting sideline. Like when I'm teaching this um, over at Gateway, and we get to the objects and classes, and I'll just give you an example. And I forget if it's unit 8 or 9. I think it's unit 9. Um, and so, okay, so I'm going to give you guys a very quick example here. This is a sideline, totally. And I'm trying to remember which one of these comes first. I think it might be address or something like that. So we build the class files first. Okay, so boy, I did not want it to go up there. Let's try it one more time. I'll put it in here. There we go. All right. So I want you to notice that this file that I'm bringing up, I'm building a class called address, and the file name is the same as the class name, however, with a lowercase letter to start, but the class name's a capital letter. That's a convention in Python, right? Then I have the init function, and I want you to notice how, I'm using a different book there, and that book, when I'm sending in like the house number, when I apply it internally, I still use self, you notice that? But the convention that book likes you to follow is that you put an underscore in front of all the internal variable names. So there's a differentiation. And so that when you look at it in your code, it's evidently apparent that you're dealing with an internal data property and not an external one, right? Then we go to W3 schools and they're like, whatever, name, who cares? And that's really weird, right? So this is actually a nice little example to throw in at this point, because here's a class structure that has many more data fields. So instead of like 1 or 2, it's got 6, right? We have self coming in, that always has to be there. So then all the ones that we're sending in, and then we have this other one that is preset. So this one becomes optional. I don't have to send in an apartment number. Why? Because some addresses don't have apartment numbers. Some do, some don't. So if that last piece of information isn't sent in, it would automatically set it to blank, right? That's how it works. Now, inside this class structure, there's also a method that prints out the address, and one that checks to see if one postal code comes before the other. These are goofy little things. But notice there's no code inside here that makes it run. This is a standalone file. To run the file, this is how we do it. We would create a separate Python file, and here comes the import. So I'm importing from the file called address.py. I'm importing the person class, or excuse me, the address class. Right? Confusing schools here. Then I go ahead, I instantiate a house, send in a bunch of data, one without an apartment number, one with an apartment number, my house, your place. Then I print them out to show that they work. And I could run that right here if I wanted to, but regardless. And then I also test this other method, but this is more the typical approach. And this is really the approach that I would ultimately recommend when you're writing stuff like this. We're doing pretty simplistic examples. This is a 1 credit class. This is coming from a 3 credit class, where the homework is a little bit heavier, and that's the approach. So you have a class file and a separate file. It's a blueprint, right? Then I can use it to run programs. I import it, and I can use it in any program I want. All I have to do is have the file available. Greg threw in the question, where does the imported file have to live, relative or specific path? Aha, okay. So the easy answer, Greg, is if it's in the same folder, it will automatically find it. or it's in where all the standard Python libraries get stored in your operating system. That's the answer. If you did the Anaconda version, by the way, of Python, and I'm just going to do the sideline on this. This we're going down the rabbit hole pretty deep, but that's okay because I think you guys are generally on board here. One of the reasons why a lot of people use the Anaconda distribution of Python, right? And I know you guys did not, right? But at Gateway, we use it for a number of reasons because Python at our school leads to either the web program or it leads to our AI data analytics program where Anaconda is critical, right? Because we use a bunch of tools within it. But one of the features here, it's like aside from being able to launch programs, are all the environments. And really what this stands for are all the libraries that are stored. So if you notice all these things with green check marks, these are standard libraries in the Python library folder. And some of them automatically get called in, but other ones I have to explicitly call them to use them. And if they're here and they got a green check mark, I can call upon them and use them in my program. And notice how many libraries there are. There's not like one or two. I mean, there's like 1,000 of them, right? And if I wanted to add additional ones or take one that I created, I could throw it in here and build it in, and it would automatically execute. Alexis, you have a question.
I guess so for Java in classes and stuff, we use setters and getters. Do we have like a similar thing, or is like this basically the extent of the classes?
Right. Excellent question. We don't technically have getters and setters, right? So, okay, so what Alexis is referring to, and this is, once again, a higher level concept, is the ability, like when you have a data property like this. So normally, like in a C style language, we would not declare these inside of a method. We would list them at the top of the class. That's the typical spot. All your data properties and fields would be listed up here as regular variables. And then you would have separate functions that would allow access to either set the information for that variable or retrieve the information from that variable. And it's such a standard feature that a lot of the high-powered IDEs, like once you've created your class structure and defined your internal variables, you just do like a right click and just say create setters and getters, and it does it automatically. Right. And this is really kind of a deeper concept. Python does not work that way, but you could, and I'm just putting this out there, you could create functions that do that if you're comfortable with that syntax, and the words get and set are still used, right? So like get implies to receive information, set implies to set the information. In Python, I just brute force do it. I don't have to call a function to do it. Python just does it for me, right? So these are syntactical differences, Alexis, but a very pertinent question. All right, so here we have the prompt. We didn't even try this yet, right? So let's try this with the third person here, and we're going to run it. So it did create the two people, myself and my friend, and then now it's prompting me. So I'm going to put in what's my other friend's name. We'll say Paul. How old is your friend? I don't know. He's probably older than me. That's why he's my best friend, because he's older. Right? And so I put in his age, but okay, it didn't show me the stuff. All I did is type it in, right? I didn't get to look at it. Okay, so I failed on that account. So what we should do here following this is something like this. So we'll call the object we created. We'll call the property and put it on the screen. So we'll just run this again. So I'll just put in the same info, say Paul, he's 62, and now it's grabbing it, putting in the object, and putting it back on the screen. Okay. These are simplistic examples, mind you. Okay. All right. We do have that helper function piece, but I'm going to save that until we get to lab 3. So right now, I'm going to call this lab done, and we're going to move on to lab number 2. Guess I can do it this way. All right, so here's our second lab. And this one, let's do a little reading here. We will add the string, the str function that we read about right when we did our little lecture stuff. And then we're going to add another custom method to a class, as well as iterate through a list of objects. So that's kind of, we're going to do a bunch of different things here. So with this one, we're going to create a class called pet. And I think what, would kind of be fun on this one. Let's create this class as an external file. Let's try that approach, right? Since I've already presented it to you, because it's not really that hard to do. Just have to make sure all the stuff is in the same folder. So just follow with what I'm doing, we'll be okay. And then it will give us practice on doing imports, which I think is useful. All right. So I'm going to bring the Explorer panel back up here, and I'm going to begin by creating a new file. And we're told to create a class called pet. So I'm going to create a file called pet with a lowercase p. So this is going to be pet.py. All right. Inside this file, I'm going to use the keyword class. I'm going to create a class called pet with a capital P. And I'm going to begin by defining my data fields in my init function. So I'm just going to do my def double underscore init, double underscore parens, self, the self-referring always has to be there. And we are given more information here. I guess I should probably read it. The init method should have 4 parameters: self, name, species, and sound. Okay, so let's do self, name, species, and sound. So let's set up the name, self. And you know what? I'm tempted to kind of use the approach I use over at Gateway, which is do an underscore, right, to make it different. I'm not going to, by the way, but I'm just pointing out that we could, right? And if you wanted to use different variable names to not confuse anything, that's on you, right? Okay, so I have all the data fields defined. Right? The other thing that, I'll tell you, the other thing that's really weird, right? If you're used to like a C style language like C# or Java or C or whatever, and you're setting up these internal data properties or fields, if you will, you have to declare the data type too, right? Like an integer, a string, a float, a list, a dictionary, an object. Could be an object too. That's really weird. And in those languages, you also set what we call access modifiers: public, private, static, etc. And that's a whole separate discussion that we're not talking about here. But if you've had the C# class, or if you learned Java or whatever, you'll go, oh yeah, I remember that. And Anthony, hopefully you're doing that. Alexis, hopefully you're doing that. Mike, hopefully you're doing that. Going, oh yeah, I remember that. That was kind of a pain. All right, we're going to have a string method or str method, which is if we call the method to print, this is what it'll print. That's basically what this method does. And we're just going to put in a return statement here and then a string. You don't need parentheses or anything like that. I do want to do the F string approach. So I can call the internal variable. So for example, I want it to output the name of the pet. So I'll say self.name. All right, so the name, so like, my dog is a, we'll give the species, right? So self.species. And so when we print the object, it'll say the pet's name is a, whatever is a cat, that kind of thing. That's what this will do. And that's all this function will do. The other function that we're asked to create, I'm just going to go back to the instructions here, right? So we're going to create a string method to output all 3 parameters. Okay, well, I guess I don't have the 3rd parameter in there, right? You know what? let's leave that out for right now, and I'll handle that in a separate action here. So let's create the other method. Create a method called speak. The method should print out the species and the sound the pet makes. Okay. Create a list of 3 pets, iterate through the pets. Okay, all right, we'll do all that. All right, so here comes my first self-created method. No double underscores here. This is just, this is like a regular function, but it's internal. I'm only using the self-referring. I don't need to send data into this because the data for the sound that the animal makes is already built into the object. I just have to utilize it. So this is just going to do a print command, and this will say something like this: with self dot, oops, let's try that again, dot species goes self dot sound. So cat goes meow, for example. Dog goes woof. Bird goes tweet. You know, something like that. Fish goes whatever that sound is. Being silly, I know. Now I'm trying to
How do you
make sure
spell that, by the way?
I'm not sure. Let's ask Chat GPT how that's spelled. It'll probably tell me. Okay, so I'm looking at the stuff that I did last time. So this is actually all we need to put in this file. This is our blueprint. This will not pollute our regular program. So like in the previous example, we built the class at the top, right? And this is non-executing code, right? So like, for example, if I go to pet right now and save this and hit run, it doesn't do anything because it's not supposed to. It's a blueprint. It's not a house, right? So when I run it, I don't get a house. I just get a blueprint. Right? And if you look at the output, there's no output. It tells me it ran okay. Right? It did exactly what we told it to do. All right. Now we're going to create another new file. And this is where, all right, so like you can see that the pattern we use at Gateway is if I have a class file, I demo the class file, and we can use the same approach. But let's be more creative and let's just call it my pets.py. And you know what? I'm going to also do this. This is goofy, but I'm going to say lab2 for my own sake in the future. So there it is. First step is we have to do an import. So I have to say from, okay, what file am I pulling it from? From pet, lowercase p. So from pet.py. I don't say .py here, but I just say from pet in the same folder. Import. What am I importing? Not imports, but import pet, capital P. Anthony. Okay, if you're talking, I'm not hearing. Yep, you're muted, sir.
Can you hear me now? Okay. Sorry about that.
No
So
problem.
going back over to the pet file itself, why didn't you put everything in just one line? So saying like self.name is a self.species goes self.sound, for instance.
Because when I call this command,
Mhm.
I'm wanting to say cat goes meow.
Okay.
The
Got it.
why is that's what I did last time,
Got you. Understood.
basically. And you guys, this is a lab. This is not like a right or wrong kind of thing. This is experimenting with how the stuff works. Keep that in mind. That's what the labs are about. Is let's try it. Let's see what happens. You know, and if we don't like what it's doing, we can change it. Right. I mean, this is the beauty of the lab versus the assignment where you're kind of doing it on your own. All right. So back over to this one. So from the pet.py file, we're importing the pet class. Okay. So from there, we can start to write code. So I want to create a couple of pets. Okay, so here it goes. So I'm going to say my, and you know what? I'm always doing this like underscore stuff here. And I'll tell you what, this is a byproduct of copying from Patrick Gerber. I'm just, I'm not trying to slam Patrick, right? Some of you guys might have him as an instructor here. But this is his naming convention for objects. And I would not normally name stuff like this. The way that I would normally do it is I would use camel casing is I would do it like this. That this is me, right? So I'm just going to do that just to show you that you don't have to do underscores. If you find that easier to read, go for it. There's no rule, right? Right. So now I'm going to create a pet. So I'm going to call the init function basically, and notice how the handy little thing comes up. So I need a name, a species, and a sound. So I'm going to use my own pets here as an example because Abby is sitting like literally right under my chair. And if I roll backwards, I'll probably run over her tail. So I got to make sure I don't do that. Abby is a dog. And the sound she makes is woof. And actually the sound that Abby mostly makes is she goes, oh, that's a whole separate story. She loves to howl, and she very rarely barks, but I swear sometimes she can speak. I don't know if you have pets like that. Okay, so now I'm going to do another pet, and this pet I'll put in one of our more recent cat acquisitions, Mojo, who we literally found walking the streets of Milwaukee. We scooped him up. Yeah. Didn't belong to anybody. And he's a cat, and he goes meow. So I have my first pet, and now I have another pet. All right, another thing I'm going to do, all right, and we can kind of play with this a little bit. So for example, if I want to let's do a little experimentation first. Let's see if this even worked and see if we can print these out. So given the fact that we put in a string method, an str thing, that allows us to just print the object directly. So I can just print my first pet, and I can just print another pet. So this should work. Here comes the run. There you go. Abby is a dog. Mojo is a cat. Notice it doesn't say what sound they make here. Okay. You might like that. You might not like that. I'm going to tell you what. I'm going to do a little tweaking here. I'm going to make the first return statement put in a period and a space. And then I'm going to put a period at the end of this. So that one, ultimately, I can ask it to print and then tell it to speak afterwards. That'd be kind of interesting. You know what? In fact, let's try that. It's kind of goofy. But I could say, my pet, and then I could call my first pet dot speak. Let's see if that even works. Sorry, let's run that.
I had the same thing happen where it printed none, like after the sentence. Like, why did that happen?
That's a good question. All right, so dog goes woof. So this printed first, right? And then it printed Abby as a dog. So maybe this isn't the way to do it. It's really kind of the answer. Maybe this is a concatenation thing. Let's try that. Okay, doesn't like it at all. All right, look, you know what? Let's do it in a more simple fashion. Let's just do print. Oh, duh. Okay, I don't have to do that. Okay, so here's the why it happened. Alexis, this is a duh, right? Here's the duh. This one is returning a string, which drops into the print statement and prints. This one just does a print. That's the why. All right. Okay. So So I don't have to ask it to print again. All I have to do is run it. That's all I have to do. I just have to do that. Okay, let's try that. Okay, Abby's a dog, dog goes woof, and Mojo is a cat. And then if I did this here and change this to another pet speak, let's run it. So Abby's a dog, dog goes woof, Mojo's a cat, cat goes meow. Okay, so we're successfully creating the objects, we're successfully getting them to speak and do all that stuff. Okay, now let's make it even a little weirder. This stuff's all good, but I'm probably going to get rid of it. But we were told to do another thing in the lab, which is to create a list of pets, right? So I could just do this to start with, or if I want, I could populate the list right away. Like, so one way I could do it is just to take the pets I've created and just add them to the list brute force. So in other words, and I want you to think about what we just did here. When we were creating a list of like music genres, remember that? We were just throwing in strings. So it was a list of strings. Now I'm creating a list of objects. Weird, but cool at the same time. Another thing that I'll tell you is that a lot of times when people write complex lists, sometimes they prefer to kind of lay them out kind of like this on their screen, especially if they have a whole bunch of them. I don't know if that's really functionally necessary. I'll just leave it like that. But that's my list of pets. I could, and here's kind of like the weird thing is I do actually have more than those two pets, right? We also have like 4 other cats and the Amazon parrot at home, right? Yeah, we're a pet household for sure. And at one time we had a turtle and guinea pigs and fish also, right? And other birds. Long story. All right, but what if? So I create this list of pets now. What if I want to add another pet? So I could do pets append, right? If I want to add something to a list, this is where it gets kind of interesting. And then inside parentheses, I can call the pet constructor and build another pet or add another pet. So I'll tell you what, I'll add our parrot, whose name is Poco. And she's an Amazon, but let's just call her a parrot. And the sound, what sound does a parrot make? Oh my God, parrots are very, very loud, by the way. Caca. That's what I'm putting in there, right? If you guys know what movie that came from, you get extra credit. It was a horrible movie, but that, for whatever reason, stuck in my brain. All right, so we already tried like this approach, and what I'm going to do here is I'm going to comment these commands out. You notice I'm using the triple double quotes, right, to do comment marks. And I think the other part of the lab is to add another pet, right? So this is appending it to the list. And then to run a for loop to print out all the pets. Right, so here goes. Here's the for loop. For each pet in the pets list, I'm going to do the following. I'm going to print the pet, whatever the current one is on the list. It'll start at the first one, go to the second one, go to the third one. And then I will make the pet speak. Let's do this. I know you guys are probably still typing, but I'm going to go ahead and pull the console up to there and do the run. Okay, so Abby's a dog, dog goes woof, Mojo's a cat, cat goes meow, Poco is a parrot, parrot goes caca. All right. And that is not a byproduct of running these commands, right? This is all in the loop. So what it shows you is that command here as part of the append got added to the pets list. So there's a third entry here, and I'm able to output it. This is the string method. And then I'm also able to make it speak. So we have these objects now that we've created that have multiple data fields, have a string method, and have a speak method. If you wanted to experiment, and this is the kind of stuff you should do, right? You know, this is kind of what the labs are for, really. But what if, like, for example, I wanted to say, well, you know what? Maybe a parrot doesn't say caca, maybe it says squawk or something like that, right? So what I could do is I could find that position in the list. What position in the list is it? Okay, let's do that as a thought. This is position 0. This is position 1. And Poco's in position 3. So what I could say, and I'll do this in a separate statement, we'll say pets position 3 dot sound equals, I don't know how you spell squawk, how about toodle doo, something like that, something goofy, okay? And then we'll run the loop again to prove that it changed. So here comes the runtime. Oh, it doesn't like it. What does it like here? Pets position.
It's supposed to be 2, not 3.
Ah, yeah, thank you, Alexis. Right, and you know what? And Jackie nodded, right? I said position 2, but then I typed 3, and nobody stopped me. Thank you. All right, and there we were changing the property inside of the list. So we haven't really gotten to these kind of features yet, but we're getting there, right? So this is actually kind of a fun, goofy little program. A lot going on here, right? This is a lot of stuff to absorb all at once. So like, take a breath and think about it. If you have to like review the videos or the lecture materials, we are starting to build objects with it. In the first iteration we did, the class is right in the same file that we're running it from. The second version, we made the class file separate. Then we created a program that imported it, created some objects, put them in a list of objects, added another pet, iterated through, changed one of the data fields. So this would be a setter, Alexis, right? And then we ran the loop again, and we did see that the information changed. Right. Lot going on here. I think we're due for another break. So we're at 12 after right now. Let's make this a little longer break. Let's go to 8:22 or 8:23. So a 10-minute break here, folks. All right, we're back from break, and we're going to start working on our lab 3. And if you remember, when we looked at lab 1, they wanted us to build this like helper file that would help to check the input of an integer and a couple of other things. And I put it off at that point because I really didn't think it was necessary for that stage of the development, but I do think it's becoming necessary now. So I'm going to start by doing that task first. So I'm going to come back here into our module 4 labs folder, and I'm going to create a new file, and I am going to call it helper.py. And really, you can call it whatever you want, but the way that I basically see this is we're building a file that's going to contain a collection of functions that we can use in any program that we want, and we can call it in whenever we want. So the one that they're originally asking us about is to do an integer input and to check to basically make sure that it's valid. And here's where we're going to use the try except statements, by the way. So we're going to have like this external function that we call in that's going to ask a person to enter a number based upon whatever prompt we give it. So it'll be a variable prompt, right? And then we'll make sure that it's okay. And if it's not okay, if it's not a whole number, then we'll have them do it again. Alexis, I see that you have your hand up. You're muted, by the way.
I was wondering what the pi cache was.
I'm trying to remember where that.
It's in the Explorer in VS Code.
Oh. That's just a byproduct of the code running. So like it creates a cache file relative to the pets that we have in memory because I'm building an external class file. It caches the objects that are created from it. So in other words, it builds them from this blueprint and it throws them in memory. And that's kind of like a written memory location on the hard disk. It's a temporary file. So it caches the objects inside of that file.
Okay, so like if like are we able to delete it or just leave it?
I would just leave it. I mean, if you want to delete
Okay.
it, it's not going to harm anything.
I just
but
wasn't sure if it was like kind of similar to node modules in like JavaScript or something. So I just
well,
wanted to make
you
sure.
know, I mean, if you delete it while the program's running, it's going to cause problems. But if you delete it when stuff's not running and then you run a program that requires it, it's just going to recreate it.
Okay.
You know, it's kind of like a temporary file. And you know, it's not that it's an invisible file, but the fact that it's got that double underscore after it kind of tells you like generally you should probably leave it alone, you know, typically. And if you notice, like when I was bringing up examples from the other school, that's kind of what happens here when you run these types of files. And notice that the cached class files basically reside here. So like whenever any of these get instantiated as objects, they get stored here for temporary retrieval. You know, it's a cached version of the blueprint, basically. I can't tell you specifically what the usage of that is, but my suspicion is that it retains the features of the objects in a spot where they can easily be retrieved. Right, so kind of dynamically, that would be my speculation. Not, you know, and I would say you should read up on that if you really want to make sure what it does. All right, I'm going to come back here to the helper file now, and I do have at least one function I want to build to start with. The first one's going to be the get int function. And what will feed into this is any text prompt we want to give our user. So in other words, if I want to prompt the user for like, hey, please enter a number between 1 and 10, or like I have a specific ask, that's going to come in as a string in that area, and then we'll put that on the screen. Now, I'm going to put this inside of a loop, forced to run. So we're going to say while true. So in other words, we have to like find a way to exit this loop, basically. The first thing that we're going to do is we're going to do our try statement. So the try part of a statement, and I don't want the bool thing there, is the normal code we would operate. So for example, if I'm having the user enter some sort of an integer, I probably want to store it. I'm probably going to convert it to an integer, and I'm going to do the prompt, and the input prompt is whatever text we send to the prompt. So in other words, I would feed in the prompt from it externally. So I'd call get int, and I would throw in the words that I'd want to prompt. Please enter a number between 1 and 4, you know, that kind of thing. It would grab the input, turn it to an integer, store it in the user number. All right. And then when it's all done, it would return the user number. Now, what's interesting about this is this would break us out of the loop. Right here, this would return, and we're out of the loop. Back to where it was called from. Assuming they entered a valid value, we're all done, right? Okay, but we have the situation where they might, either willingly or unwillingly, enter the incorrect information, in which case I want to let them know that. So I'm going to say a message, for example, please enter a whole number. And then what's this going to do? It's going to put that message on the screen, and the loop's going to run again, and it's going to prompt the same prompt again. Please enter a whole number, enter a number between 1 and 4. And it's just going to keep going. And the only way they break out of this loop, think about this, is if they type something valid. Otherwise, they're stuck here, right? Forever, right? Well, for as long as we want, but you know, at this point, it would be forever. And I mean, I think this is a kind of a clever little approach. The other thing that this kind of brings to the table is there's error handling sort of going on here. So like, let's see what happens when we type in a word and we call upon this, right? So in this case, and I want to make sure that I'm using the right one here. So what we're going to be building here, so here's where we're going to edit an object in the list. So we're going to create a class called grocery item. We'll pre-populate a list. We'll list all the groceries, update a quantity, and exit the program. And all of this, as you can see, is driven by entering numbers, right? So this is where I think it's helpful to do this. Now, in the next lab, and I'm going to fast forward to that, we're going to use the same thing, but I think with this one, and I'm looking at because I have another function built in here. And this is where we do stuff in a range, and I don't think it even applies here. So I think for now, our helper function's okay. So in other words, what this alleviates from our main program is I don't have to add this code to the main program. And because this is particularly useful, I can reuse this over and over again as many times as I want in any program that I create. Right? Right now, there's only one function in here, but that's all I need for right now is one function. All right, so Control S to save. If I run this, nothing will happen, right? Because this is just a function. That's all it is. The goal of this is I will import it into another program, right? So now we go on to the actual lab that we want to build, which is lab 3. And let's start doing these tasks here. So the first one is to build a class called grocery. And I'm tempted to do this as an external file again. We don't really need to do that because it's pretty simplistic. So I'll tell you what, let's build it all in the same file. But if you want to do it as an external, that's on you. So this one I'm just going to call module for lab 3 .py. Oh, and look, I put it in the wrong place. We were talking about that. Yes, I want to move it. All right, so I didn't want it in my cache folder, by the way. Right. Hello, Shravan. I see your message, and thank you for letting me know that you're here. I will mark you as present. All right, so first step is we are going to do an import at this point. So we are going to import from the helper file, or we're from the helper file, we're going to import the get int function. And notice how cool that is, right? Like once I got like the import thing typed in there, I start typing, it recognizes the files there and it reads the function automatically, and I don't even have to type the whole thing. Thank you, Python. Now we're going to create a class, and we're going to call this grocery item. Notice the capital G to start. We're going to set up an init function, double underscore, and parameters. We were told the list of parameters. It always has to start with self, and then we're going to have the name, the category of the grocery, and the quantity. And don't forget your colon at the end of the statement. And then, like as we've done with all the other ones, we're just taking the values that are being sent in from the outside world, and we're applying them to the internal or the self variable version of it. So self name equals name, self category equals category, and self quantity equals quantity. Right, so that's our init. We're also going to build a string function here. So we're going to create the string function. And this is simply going to output, the basic details of each grocery item. And they have a little format that they use. So I'm going to try to follow that somewhat. We do need the self-referring. And here we will just go directly to a return statement where it's going to return a string if I can type it. If I can type the word, that is. I'm going to make it an F string, so I'm putting the F in front of it. And then we're going to output first the self dot name. And then we're going to do a space, a dash, a space. And then we're going to put the self dot category. Oh, and I misspelled that, right? Category, not good. I'm fixing it. Not that it really matters, but it's bugging me already. So that means in the long term, it'll bug me even more. And then we will list, after a colon and a space, the quantity. So if we ask the object to print, this is what we'll display. The name dash the category colon the quantity. So like, I don't know, American cheese dash dairy dash 3, something like that. All right. So that's the entire class. I think that is all the stuff we have to put in there. Okay. Then we're going to create a menu, right? So we're going to have a menu-driven program again. And I'm going to do this in a little bit different fashion, right? So like it does also say to pre-populate a list of grocery items, and you guys can type one up. I'm going to copy paste. If you ask me very, very nicely, I might even put it in the chat to save you typing. All right, so I'm going to just kind of throw this in. Here's my list of grocery items. So this list contains the call to create, right? So like it's full of like junk food, basically. So we got Ruffles, we got a Yasso bar. I'm not really sure what that is, but that my students told me to type that last time. Chips Ahoy and espresso. I have a drink, junk, and then the quantities of those. And then I'm putting in these little numbers here. These are the index numbers for their position in the list because this is going to become important, right? And remember last time, even though I stated it like position 0, position 1, position 2, I still screwed it up, right? You guys are all nodding along, and even though like, yeah, okay. So that's, if that's helpful for you, do that. All right, so let's go to creating the menu. And we're going to, be creating a program here that we're going to allow to run because we want to be able to do the things many times. And it's got a menu, so the user will choose when to exit. So we're going to do that with a while loop again. So we're just going way to the bottom here somewhere. And I'm going to say while true. And then normally, like what we did in the past is I had a function that created the menu and did all that. But I'm going to do this a different way. I'm just going to do a print statement. In fact, I have it pre-created, so I'm just going to do this. I'm trying to make it as simple as possible, basically. So I'm going to print out on one line, list items, 2, update an item, 3, exit. That's our choices, right? And then we're going to get the user's choice. So I'll create a variable called choice, but this time, instead of just prompting, converting to an integer and hoping they did it correctly, now I'm going to call get int. Remember, this is coming from the helper file. And I am going to use inside of here, this is where I put my prompt. I'm going to use an F string to do it, by the way. I'm going to do a tab stop, so it's going to go in because that's what the example shows, by the way. And we'll ask them to put in their selection, right? So that's going to be 1, 2, or 3, right? List, update, or exit, right? get int, so I just show you the mechanics of what's going to happen here, is going to receive the prompt, go into a loop, take that prompt text and put it on the screen, convert it to an integer, store it, return it if it's valid. If it's not valid, it will throw an exception, enter a whole number, and then ask the prompt again. So the first thing I'm going to try is to break it, right, when I run it. All right. So, and we're not quite there yet, but I'm just kind of saying that up front. Okay, so that's handling that piece. So this is getting input as an integer from the user with error checking. All right. So now here comes our if else. We'll say if the choice is equivalent to 1, we will list the item. Else if the choice is equivalent to 2, we will update an item. Right. We still have to build those. That's why they're underlining yellow. And then the way I wrote it last time is I just went right to an else and then did a break, right? So otherwise they're typing 3 and they're exiting. But if you guys want to follow the pattern that we've been doing on some of our other programs here, we could put in the elif, the choice is 3, and then do our break here and then give them a message. But here's my question for you. Right? What situation would catch down here if they don't enter 1, 2, or 3, right? So whatever they're entering is not 1, 2, or 3, but it's still an integer. All right. So, all right, let's just do an error message and say, what the heck is wrong with you? Or something goofy like that. You should be polite to your users and give them a nice message. I'll just say that is not a valid entry. Please try again. Right. And if you want, once again, oops. That's just something I feel like I can't avoid most of the time. So there's our menu driven piece. We are going to need 2 functions here. And I'll create the first one first. Let's do def list item. And I'll worry about what goes into it. I'm just going to do a pass for right now. And then we'll do def update item. Let's spell it right though. And once again, we'll do a pass. Okay. So now, as we're kind of like doing this activity, there's another teaching point here that I want to kind of throw into the mix. We're starting to run programs that we can keep running, right, until the user decides to exit. We're also building programs that are working with complex objects and data structures, and we're able to store those structures, add or change features of those structures, right? Like, so for example, if I want to change how many ruffles I'm buying, if I want to up that to 4, I can go in there and change that number. We figured out how to do that too, if you guys remember. And the process of like taking data and reading it in, storing it, reading it back, changing it is part of like the fundamental operations of kind of working with a database, right? And if you guys are taking a database class, perhaps, we call these operations the CRUD operations. And here's what that acronym stands for. CRUD stands for create, read, update, and delete. All right. So the create process right now, we're doing brute force. The read is going to be the list. The update, well, is the update. And then the delete is where we get rid of it all, right? And we haven't built those yet, but that's kind of what we're building up to. And a proper application that works with data that's stored can ideally perform all of these actions. So to create the information, to read the information back, to change the information, and then to destroy the information. And some people, when they do CRUD, they say create, read, update, destroy. So you hear both versions. But when you guys take a database class or you maybe study with a different instructor, very likely you'll hear this. And it's one of those data nerd things, by the way. It's like, yeah, we built the application, we got all the CRUD operations, and they're like, what? What's a CRUD operation? Okay, now right? So I'm cluing you guys in to the terminology of it and where we're building to, right? We're not quite there yet, but ultimately, when we get to the end of this class, we'll be performing all of those operations on the data that we're building into our applications. And keeping in mind that this kind of feeds you into other aspects of the data program here, it becomes very useful. Jacob, I see you have your hand up, sir.
Yeah, I was saying when you said CRUD, for some reason my mind went to cron, like a cron job in Linux. For some reason, my mind went to that.
Yeah, interesting. Right. And it's all on how quickly I say it and poorly I enunciate it. Right. Right. And what Jacob's referring to is, yeah, when you're working on, let's say, a web-based server, usually you're running a web application of some sort. You can create what we call cron jobs, which are basically time-based applications, right? Like if you want to, let's like do a backup every Monday at 3 a.m., you can write a cron job that does that, so you don't have to go into work to do it. The operation happens on a timer. Right? That's different than CRUD, but these are, we'll call these right, and I'll just use the same symbols here. The basic operations of working with stored data, right? Or databases, right? Or database information, basically. I think this is a really important concept to wrap your head around. And I know this is kind of a deep topic to throw in at this point, but it is a necessary one because it's kind of what we're doing. Like we're entering in the information. Like I said, the create process, we're doing brute force. But I could also write a thing. Think about this. We did it last time, right? We can append an object with all its data fields using prompts and an append. And then the one that we haven't learned yet, because we really haven't formally learned about lists deeply, is how to remove an individual list item. That's a separate skill. Right? We're getting there though. And then, one step at a time, as they say. All right. So let's work on listing items first. And the way that I'm going to do this is I'm going to begin by looking at the instructions. All right. And I'm going to show you why I'm doing this. Right. So, like, for example, the way that we're doing this, and I'm just kind of looking at, like, when we're listing. All right. So this is updating a quantity. This is listing the items. So it would number the item. Now these are backwards, right? So these are I think backwards of our output statement. Well, we can fix that or leave it as is. So like the category, the item, and then the quantity. That's actually how it works. And then for each one in the list, it's numbered, but the number is one greater than its index position. So now you're understanding why I put in the index numbers here to kind of keep that in mind. And even though, these are going in a certain order. So this is interesting. It's a name, category, and quantity. And then here in the output statement, I could flip these. And I think I'm tempted to just flip it to match the example. So I'm going to put the category here, the dash, the space, get rid of those. So now it'll say produce, and mine will all be junk, beverage, junk. Right, that's what my list is going to be. And then the quantity to match what we see on the screen. So we can switch them. It's okay. Right. This is just output. Right. All right. So let's go back here then. So if I'm going to output the information and add an index number in front of it, well, then I have to accommodate for that then how I do the output. Okay, so I'm going to take a look at that output again. So we're going to output the number 1, and then in principle, we should just be able to output the string, and it should work. So, but I want for every time I print these to print the number at the beginning. So I want to do whatever the index value is plus 1. Okay, so here's what I'm going to do. I'm going to create just an index variable. I'm going to start at 0. And then every time I run my loop, I'm going to add 1 to it, right? Okay, I think you guys will see where I'm going as I type this. So I'm going to say for each item in items, so items is my grocery list, right? With all the objects within it. I'm going to do the following. I'm just going to do a print statement. And then I'm going to output, and I probably do this as an F string. So let's do F. And I think we do the index value, the I, plus 1. Right, so the first one will be 0. So it'll print 1. All right, and then, okay, so the I is a variable, so it has to go inside of curly brackets. So the first one will print 1, a period, right, a space, then it will just output the string. Alexis?
Yeah, I was just curious if there was a way to like have the index within the class rather than since we're already printing that string out in like using the class, is there a way for it to like can self like know what the index is somehow? Like is there a method for that?
Yeah, there are ways to do that. I think this is a cleaner approach, real frankly.
Okay.
Right. I mean, yeah, and Alexis, it's your experience speaking here, for sure, because
Yeah.
we did a style language, that's totally how we would do it. I'm trying to mimic the output they have on the screen, which maybe isn't the smartest thing to do, because now I'm going to call upon the string method to print the rest of this. Right. So, and I'm going to tell you, as I do this, I'm a little pensive about it because I'm not sure I remember the syntax for it. And I don't know if I have to do, okay, so I think I have to put it in curlies, and I think I have to say that particular item. And I don't know if I can do this, if it'll let me
No,
do it.
it was just the item based off the last, at least, lab that we did. We just did the
Right, but see,
item.
okay, if you look at like what this is outputting here, this matches our string output. So really what I'm doing is I'm taking that string output and appending this, a period and a space to it. So I should, maybe that's all I need to do. You know what? I have to test this, I think. You know what? Let's do that. Let's just run it and test it right now and see if this list works. Oh, the other thing I have to do is after inside the for loop, I have to increment I each time by 1. So I got to do that. Okay. Let's try running this and see what it does. Right. You can tell I'm not even sure, but it's pre-populated, so I should be able to just list it. Okay, so it is working. Okay, so that's simple. And yeah, it's like junk dairy, junk drink, junk dairy, junk drink, something like that. That sounds about right for Wisconsin, right? I see a couple of little things I don't like here, like the selection should probably have a space in it. Where do I fix that? Well, that's going to be here, actually, right? No, that's going to be here. I need a space there. And this is kind of like goofy persnickety stuff. I think I need a blank print line here. All right, so that's what I'm going to do. I'm going to run it one more time, right? So I'm going to run 1 to run the list. Well, actually, it never stopped running. Interesting. All right. Now we're going to run it again, right? Because we control when it stops, and I never stopped it. How do you like that? Okay, so listing the items. All right, the selection looks better. There's a blank line in between, and then we go back to the menu. I'm going to argue too that with the menu, and this is just me kind of really getting particular here, I might say do something goofy like then do another blank line. I can just do it all in one print statement. All right. This program is still running, so I'm going to hit 3 to exit. Let's run it one more time. And my goal here is just to make it look a little nicer, for as goofy as that is. So list the items. It listed them, and then back to the menu. Okay, I think that's all right. 2 doesn't work yet. 3 we know works because we've done it. Let's put in a number that isn't supposed to work and see what happens. All right, so it gives me the prompt again. And I put in another one. Now I'm going to be really bad and type in text. Interesting, right? So here's our error checking coming into play here from our helper file. So I'm not putting in a valid integer instead of crashing. Now think of our old programs. If I would enter a word in where it was expecting a number, we get like a compiler error, the program would stop, you'd be like, or whatever. But now we're handling it gracefully, and it's just saying, please enter a whole number. So I'm just going to do it again, right? So I'm going to put in 4. That's still not right. Not right. Please try again. So at least I have a chance to control it now, and the program doesn't crash. This is cool. I don't know if you guys are picking up on that or even feel that, but I feel that, and that's all that matters, right? I'm kidding, right? But we are getting the program to run, and it's handling bad entry beautifully. All right. Next, we have to do the update item. All right. So if you want to update an item, I'll have you think about this. I might want to look at the list of items before I update them to know which one I'm updating. Okay, so here's the first command inside of update is to list the items. How do you know what you're updating if you can't see it? Right? Right. Next thing is we're going to ask a question. And basically what we're going to say is, what item would you like to update? I'm going to use the helper function getInt thing to do the prompting on it. And then we're going to capture a number. And the number we're going to capture is the one next to the listed item. So if my ruffles are number 1 and I want to edit ruffles, I'll type 1. But in the list, it's position 0. So I'm going to call that variable that I'm going to capture it in index. And then here's my prompt, folks. And I'm trying to move my screens out of the way here. Here's my prompt. This is the prompt I took last time. My copy paste did not work. It's my epic fail there. And check the cleverness on this. I send the prompt in. It grabs the value. It's going to come back as a valid integer one way or the other. They're going to type in the number that they think is the right one, which is going to be 1 higher than the actual index number in the list. So I'm adding a -1 to the end of it before I even store it. Right. So see the cleverness of that, or at least assumed cleverness, right? I could subtract this later, but I think it makes sense to do it now. That's kind of my thinking. Right. I wrote this little comment last time when I was doing it, and I said, update properties of an item in a list, use the index plus the number access operator, right? Yep. All right. So in other words, here's the code. So the way I'm going to go into the items list, into a particular position. Which position? The position indicated by the index number that's already been calculated. And for example, if I want to change the quantity, right, this is what I'm being allowed to change. So I can order more ruffles or less ruffles. Then I will run the getInt function again, And this time I will prompt, and I'm going to copy paste my prompt. I don't want to type it, frankly. How many do you want? And notice what it's going to do is it's going to go into the list, into the index position, and pull back the name. So it's going to say, how many ruffles do you want? And I can type in whatever number I want. Now I could ramp this up, right? So I could have an add item if I wished. It's not being called for here. But you can see where we go, and ultimately a remove item. And once like all of those things were in there, then we'd have all the CRUD operations. But right now, we're only going to change the quantity. All right. And then once we're done doing the operation, we want to make sure that it worked. So we'll relist all the items again to see the list. All right. And believe it or not, that's the entirety of the program for this lab. I'm going to leave this stuff up on screen here. That's the stuff we just typed in. I'm going to go ahead and save this, and I'm going to do a run. All right. So let's, it says here, let's do a listing of the items. Okay, of course, I type in the code. There we go. Listing of the items. Let's choose to update the item. So it lists them again. So what item would you like to update? I want to update the Yasso bar, whatever that is. How many do you want? I don't know, 12. Okay. It relists it. I can see it as 12. And if I run the list again, the number it sticks. Right. Let's update another item. As far as I'm concerned, you can never have enough ruffles. So let's type in, excuse me, 1. And let's get a lot of ruffles. Many bags, lifetime supply. We're having a big party, so we need lots of ruffles. And you can also probably never have enough coffee. So let's get a dozen espressos. Now we could get really fancy with this program once again. Like I said, we could add all the CRUD operations. Eventually we'll get there. Or we can even write an operation where if like I take an item and I set the quantity to 0, it just deletes off the list. That could be a thing too. But this would solve lab number 3 here. We have one more lab to do. I'm going to go ahead and save this one, by the way. And let's move on to the last lab. I'm going to pull up the instructions, and I'm just going to do a quick pause here. All right, we're moving now on to lab 4 in module 4. And the goal of this one is to kind of ramp up what we just did. So we like built that grocery list thing, and we were able to show the stuff. We were brute force entering it. We were able to update a specific feature of one item. But now we're also going to look at adding and removing objects. And adding we've done before, right? So when we add stuff to a list, we do that with the append method. But now we're going to learn a method for removing an object from a list using a method called pop. And what's kind of fascinating about this, and I'm just going to go right to the example that they have here, and they show a list of fruits. If you guys remember this when we first learned about lists, this was kind of like the example, the apple, banana, and cherry. And when we run this command called pop, and notice there's a number that follows it, the number refers to the index position of the item in the list. So if this is position 0, and this is position 1, and this is position 2, if I pop 1, which item is removed from the list? Let's try it, and you'll see it's banana.
Banana?
Yeah, it's in position 1, so it gets popped from the list. This is really kind of interesting. It's like, why the heck do they use pop? Is like, why don't they use remove? You know, and frankly, there is a command called remove too, right? And that's a separate command. but there's a terminology that's kind of interesting here, and I talk about it because it is kind of a fascinating feature that deals with an aspect of programming called data structures, right? So if you guys ever go on and study computer science formally at like a 4-year institution, and you get to the higher levels of it, so you've had a bunch of programming classes, then you take these classes where they talk about data structures, which are basically like a list is a data structure, for example, right? And a lot of data structures have methods that apply to them. And the pop command actually comes from originally from a data structure called a stack, right? So a stack, the way that I always like remembered it best was like if you ever go to um, a restaurant that has a buffet, right? And you walk up, and I'm thinking of like Golden Corral or something like that. In the old days, we used to go to Ponderosa, but you walk up, and they have like, you know, the salad bar and the steak and the potatoes and all that kind of stuff. And you grab a plate, and the plates are usually in a stack. Well, some restaurants just literally stack them up on a table, and you grab a plate, right? But some restaurants have these mechanisms where the plates are in a spring-loaded thing that descend into the counter. And then when you know, like for example, if I take a plate and put it on the stack, the more plates I add, it just sinks farther down into the counter, right? And then when you take a plate off, you take it off the top. And that's a stack. So in other words, when I put stuff in a stack, the only item I can remove is the last item in the stack, right? If I want to get to the first plate, I have to take all the other plates out. And in a stack structure, they would basically call adding plates or adding objects basically a push, and then removing them a pop. So that's where the terminology comes from historically. So the fact that in Python you can pop, but you can pop a certain position is unique. Because normally in a stack data structure, you can only pull the last item, right? In Python, you can use pop to pull out a specific item. What happens with the pop, though, and you can think of it as a stack that doesn't descend basically into a counter. If I pull the plate out of the middle, what happens to the other plates? The plates above it don't like hover; they drop down and fill the list. So what happens is when I do the pop, I notice it happened again because, all right, let's run it. But it ran twice, so what did it do? It removed, yeah. All right. But the point is, if I remove banana, cherry moves down and takes its spot, so it becomes position 1. See what I mean? Yeah, that's kind of the point. All right. Regardless of all that, that's all the lecture we get there, but that's a way to remove something from a list using its index value. So we have a little bit of a clue on how to do this already. All right. Let's look at the requirements for the lab here. Create a class called vehicle, include 3 properties, make, model, and year. Pre-populate a list of vehicles, so we're going to brute force add the vehicles. Create a menu with the following options and functionality. Add a vehicle, allows users to enter make, model, and year, so not just the quantity this time, but 3 things. Create a vehicle object based off of the inputs, add it to the list the vehicles. For remove vehicle, we'll list the vehicles, get an input from the user on which one they want, and remove the vehicle the user selected. And then finally, we'll have an exit. So not too dissimilar from what we've done. So we can use some of the same approaches that we've done before and just kind of, you know, basically ramp it up, right? Okay. I'm going to go ahead and get my example on the screen here. And what we need to do first is basically build the class, import the helper, pre-populate a list of vehicles, set up our menu, and then worry about the functions, right? So that's the approach that I use, and I hope you've kind of seen my pattern here of approaching this. I'm going to do the same approach I did last time, which is I am going to just put it all in one file. You could separate them out if you wish. Right? So I'm just going to call this module for lab4.py. Okay. I'm going to borrow. So I'm going to say from helper import get int. We're going to set up a class structure called vehicle, and we will set up an init. So here's the init. Once again, we were told what stuff to put in here. So self, got make, model, year. And then we will apply those to the same self variables named the same way. So self.make equals make. Self.model equals model. And self.year, if I can type it, equals here. So there's our init. All right. Let's look at some of the output screens here and see. So they do year, model, and make for the output. So we're going to write a string method that does that. So let's do a double underscore string. We're just going to have to put self here because it's just going to return the internal variables. So I don't need to feed anything into it. And it's going to go right to a return statement. We'll use f string. And we will say following, and I'm copy pasting to save a little time here. Year, space, a pipe, space, the make, space, the model. That's our class definition. Now we're going to create a list called lowercase here, vehicles, plural. It's going to be a list of vehicle objects. We use square brackets here, and I'm splitting them. And then I have these 3 vehicles pre-created. I'm not sure why we chose these last time, but this is what we chose. I do not own any of these types of vehicles. There's only one of those brands I've ever owned on that list. You can put in your own vehicle information if you want, years, make, models. You want to add a whole bunch more to it, go for it. That's totally fine. And I know some of you guys are still typing, so maybe what I'll do is I'll actually add something I own. Capital H there. I mean, if you want to make the list interesting, you just add more stuff, basically. Believe it or not, those are the newest cars I own. And you don't want me listing all my vehicles because there's about a dozen more. No kidding. We have a whole bunch of them. There was a time I'd buy them new, and then I got smart and I'm like, I don't ever want to buy a new vehicle again and have car payments. That's just me. Old vehicle, keep it running. All right. All right, so there's my list of vehicles. Now let's do the same thing again. So we're going to create the big while loop that's going to run the program continuously and put the menu up on the screen. So I'm going to start with, let's do while true. I'm going to put my menu up. I think these are the 3 menu choices, and let's verify that. Add, remove. Okay, that's good. There's no list, right? There's no list function in this. That's kind of weird. Yeah, there's no list function on the menu. Yeah, it's kind of interesting. What's the reason for that? Probably because it's not asked for. So now I'm compelled to look, and I apologize. Pre-populate a list of vehicles. So it tells you what the function should be and what the functions do. So each one of the functions will ultimately list the vehicles. That's kind of interesting. Okay. So ideally, I think I should have a list function, but you know what? It doesn't call for it. All right. Let's not worry about it then. So there's the menu. This time I did it line by line instead of all in one print statement. We are going to grab the user choice. We are going to call the get int, and we're going to send in our prompt, and I'm just saying selection here. So I'm doing tab stop and then selection : space. That'll call that external function and validate our input. And then we'll just have a very simple little if statement here. So if the choice is 1, we're going to say add vehicle, else if choice is 2, we are going to remove the vehicle. And that really should be on the next line. Parentheses, else if the choice is 3, we will break. This has been the pattern we've been doing this time. And otherwise we say else print. It's not a valid entry. Please try again. Okay, so there's how we steer it. I know I'm going pretty quickly here, so you guys good? All right. Now, when we looked back at the instructions, each one of these includes listing the vehicles. Even though it's not a separate menu choice, we still need to build a list of vehicles. So I'm going to say def list vehicles. For whatever reason, my brain is not wanting me to type right now. So it must be a long day. First thing I'm going to do inside here, by the way, is I'm just going to do this. Oops, not that. I'm going to do this. Not hitting copy. Let's see. There we go. And I'm going to tell the users how many vehicles there are. Right, so I'm just going to do a length of vehicles. So it's going to look at the list of vehicles and count how long it is. And in this case, it should say there are 5 vehicles, and then a colon, and then it will start listing them. The process of listing them is a mechanical print process. I'm going to start with a counter because I want an index number in front of it, right? We did this on the last one. And then I'm going to do this simple for loop. And I know I'm kind of doing it quickly, but there you go. It's going to increment the counter each time. Notice this time, instead of doing the math inside and then adding 1 to it, I'm doing the increment before and then listing it. I'm just doing it a different way. So I is the counter number in front. V is the vehicle. And this is not an unusual approach that people just use a single letter for each item in a list, if they're putting it up on the screen. So it's going to list 1 colon and then whatever the vehicle is. Right. Why does it list it? Because we're inside of a print statement and we're returning the string method of the object, and it's automatically printing it. Right. So that one was needed before we can build the other ones. Let's do adding a vehicle first. So let's do def add vehicle. I added this comment last time because we were talking about the CRUD stuff, right? So this is the C in CRUD, create. So we're creating an object to add. And we're doing it through user interaction. So I'm going to ask the user for the make, and I'm going to ask them to input it, right? And I'm going to say, enter a make. And you probably already figured out where I'm going next. Enter the model. So we'll do another input. And we'll say enter model. And we're allowing them to type it, right? Now, anybody who deals with car stuff and shops car sites, it's like every car site you go to, they have a big drop down list. So it's like, you know, scroll, you find Volkswagen, you scroll, you find Passat, you scroll, you find the year, you know, you scroll, you find the engine type. If you guys ever shop car parts, you know what I'm talking about. And yeah, that could be something you could build too, but down the road. Then we're going to ask them to enter a year, but because that's an integer, I want to make sure they're entering an integer. So this basically validates that they're entering a valid integer. So I'm going to say enter a year, and this will make sure it comes back as a valid integer. So now we have 3 pieces of information that go into building an object. And now we'll call the constructor and build it. And so the way we'll do that is we'll just say vehicles dot append, and then inside the append, we will build a vehicle object. So we'll call the class, and then in parentheses, make, model, and year from within this function. So this is what they just entered. We're going to build the object and then add it to the list. Okay. When we're done, we'll list the vehicles to make sure it got there. So this allows us to add stuff. This is cool. Okay. Now we're adding, well, we also want to be removing. All right, so here's the remove vehicle. And this is the D in CRUD, destroy or delete, right? So as we did before, we're going to want to list the vehicles first before we know what, you know, how do you know what to delete? You got to list it, right? So you got to list. And as we did last time, I don't know if you remember the prompt, but we grabbed the index value, we called get ent, and then inside the parentheses, we sent our prompt, which this time we'll say, which would you like to remove? And then we're going to subtract 1 from the number to make it match the index numbers in the list, which go from 0 on up instead of from 1 on up. Then we run the pop commands, and then we call vehicles dot pop. And what are we throwing in here? Whatever index number we ended up with, you know, which is corrected with the -1. It will have removed the item, and then we'll list again to see that it worked. And I'm looking at my solution over here, and that's all of it. That's all I have. All right. Let's go ahead now, do a save. And I know you guys are still typing, so I'm going to scroll and try to get the pertinent code towards the top here. I'm going to hit it to run, and let's see what happens. So I'm going to add another vehicle, I guess. All right, enter a make. Oh, let's see, what other vehicles do I have? Volkswagen. So I added my 1984 Vanagon. I see one thing I don't like. This should have a blank line in front of it before the menu lists. So I'll tell you what, I'm gonna put in a /n here. And I'm gonna exit the program and rerun it. I know that's really goofy stuff, but you know, you see it, you may as well address it right away. All right, let's add another vehicle. Oops, not there. Let's add a vehicle. I'll put that same vehicle back in. And yes, it runs. And it's street legal. Doesn't even have power steering, by the way. I'll tell you what, you take power steering for granted until you drive a vehicle that doesn't have it. And then you're like, oh my God, how did people ever do this without power steering? Right. So now let's remove a vehicle. So I'm going to press 2. And let's remove the Cadillac, which is number 3. And see, I have an issue with this that I can't list them. You guys feeling this? I think I need to exit and I need to add that capability. So that's what I'm going to do. So basically what I'm going to do here is I'm going to go above and beyond what the lab is asking for. We have the time for it. So, hey, why not, right? Why don't we make, all right, I'm going to do it like this. This is kind of goofy. But I'm going to make choice 1 list vehicles. I mean, we already have it created, right? So we don't even have to code it. We just have to add it to the menu. This should change to 3. That should change to 4. I think there was one other spot where I wasn't happy with the output. I'm trying to remember where that is. I'm going to pause in here. There was one other spot where I didn't like the output, and I'm trying to remember where that was. I don't know. You know what? I'll run the program again, and then we'll see. All right. Does anybody need to see what I changed here? So we're just adding list to it. Okay. Let's save. Run again. Oh, but I need to add that to my menu. Okay, so I'm gonna type, interestingly, I have to type 4 to exit, even though that's not what it is. All right, so I have to update the menu here as well. All right, so we'll add another print statement. And you know what I'll do is I'll just copy the first one. And I'll say list vehicles. I'll update the numbers 2, 3, and 4. Looks good. You guys will catch me if I make a mistake, right? All right, let's try running this again. All right, there we go. So let's just start by listing the vehicles. Great. Okay, it's working just fine. And I'm going to go a little larger here on the console. All right, let's go ahead and start by removing a vehicle. So let's, okay, so why is that failing now? Let's go look at our code. Line 50, line 36. Kind of counting on your guys' eyes here to help me out. Why would that fail?
You write it again, please. I missed I just want to see the error. Okay.
Anthony, I'm not sure what you're referring to. Oh. What were you, can you do that again? I mean, we're recording this, but hey, what are you trying to highlight, Anthony?
I didn't highlight it.
That was
Oh,
me.
okay, Alexis, what were you seeing?
If you scroll up, um, there's yeah, right there.
Oh, yeah. Oh, I must have deleted the prompt, right? And that was the prompt that I thought was problematic. So when I um, clicked up into the code while it was running, thinking I was typing in the console, I actually deleted that line of code. Yeah, good catch. Very good catch. All right, save it. Now let's run it. Start with listing. Okay. And I guess I would put a line break in here. So I'm going to do this right now. This is like me being weird. So this is in list. I'm going to put in a \n here. All right. So that's on future ones, not now. We'll just keep running as is. All right, so we listed the vehicles. Now let's go to 3 and remove a vehicle. We'll remove the Ford. You can see it's gone. Now let's add a vehicle. It misspelled it. Oops. Yeah, that'll stick. All right, you can see it on the list. And it looks like we're good in it. Let's try putting in some bad entries. Let's remove the Cadillac. Then let's go ahead and exit. Okay, so this is all functional at this point. Let's just kind of do a really quick review of the code, right? Importing our helper file. Here's the helper file. This just validates that we have integer input and handles text just in case. We have a class definition for, well, this is groceries, sorry, for the vehicle. We pre-populate a list of vehicles, or vehicle objects technically. Then we have our list function, add vehicle function, remove vehicle function. And then we have the big while loop at the bottom, shows our menu, gets the user choice, allows the program to keep running. And when you start breaking this down, right, we are doing all the CRUD operations now, right? Well, there's one that we're not doing, which is the one we're not doing. We're creating, we're retrieving, we're destroying, but we're not updating. Right. So if we wanted to add additional functionality to this, that would be a functionality that we could add. And we could go in there, for example, and I'll just have you think about like the mechanics of this. I'm not actually going to code it because as we kind of move forward into our future labs, we do all this stuff. We would first have to list the vehicles to identify which one we're editing. So we pull that vehicle in. So we type in the number, pull the vehicle in, and then we decide which of the features of the vehicle we're editing. I mean, think about this. If you have a vehicle, you're probably not changing its make, model, and year it was made. So it's really not an appropriate edit. The only thing I could think of editing is maybe you'd have a field for like how much fuel is in the vehicle, or one of the features of the vehicle that you could add or remove, that kind of thing. Right. So this is a logical issue because a vehicle is never going to change its make and model and year. Right. A human, however, can change his age, and technically they can change their name too. All right. Folks, that covers all of our lab assignments here. Any questions about any of these? I'm going to go ahead and stop the recording so the recording ends here.